Number 9, it said the velocity is this, and it said how far did it travel? Well, velocity is the derivative of the distance, so the integral of the velocity will tell you the distance. And so if we're going from 0 to 5 seconds, we're going to find the integral of 12 minus 4t dt evaluated from 0 to 5. And 12 integrated would be 12t, and 4t integrated would be t squared, and we'd have to divide by 2. We're going to evaluate this from 0 to 5. We put 5 in there, we get 60 minus 5 squared is 25 times 2 is 50. Minus, put in 0 and we get 0, so we get 60 minus 50, which is 10, and if this was meters per second, it'd be 10 meters. If it's feet per second, it'd be 10 feet. I forget what the units were. Let's see. Number 9, velocity in meters per second, so this would be meters. Now this one, there was time, and the velocity again is in meters per second, so we're going to do exactly the same thing. We're going to integrate cosine of t dt from 0 to 3 pi, and the derivative of sine is cosine, so this would be equal to the sine of t valued from 0 to 3 pi, which would equal sine of 3 pi is 0 minus sine of 0, which is 0 total distance traveled. Now, did they ask for the distance or the displacement? I forgot to say. On this one, find the displacement and the distance. Oh, okay. So we have to do absolute values of these to find the distance. The displacement. This is 0 displacement. Now to find the distance, we have to do the absolute value of this for the displacement. So what does the cosine of t look like? So it starts up, goes down, and goes back up. And that would be 2 pi, and so 3 pi would be back down. And so we'd have this, and then we'd have to make this positive, and then this positive. So if we integrate from 0 to pi over 2, sine of t from 0 to pi over 2, we get sine of pi over 2, which is 1, minus sine of 0, which is 0. So the area here is 1, meaning it went 1 meter. And since this is identical to it, but twice as much, so there'd be 2, and this would be 2, and this would be 1, so it'd go 6 meters. So that means it moved a distance of 6 meters. This means it ended up where it started. For this one, if we go at 3, this changes sign. So this one ended up 10 meters from where it started. But if we do the absolute value of this is 0 at 3. So we have to integrate this from 0 to 3. And that part would be, 12 minus 4t is going to be going down. So that part would be positive. So if we go from 0 to 3, that would be 36 minus 9 times 2 is 18. So that's 18 it went in distance from 0 to 3. And then from 3 to 5, and we'd have to do the opposite of it. So we're going to do the negative of this. So I'm going to do 12 t minus 2t squared from 3 to 5, and then subtract this, so make it negative. So if I put 5 in there, I get the 60. Put in 3, and I get the 18. 18. So 60 minus 18 is 42. And let's see, 5 in there is 60. Oh, 5 in there, 60 minus 50 is 10. 5 in there is 10. 3 in there is 18. Minus 18, that's negative 8. And I have to take the opposite, so that'd be plus 8. So 8 plus 18, it's gone 26 meters total distance, but it's only 10 meters from where it started. Okay, forgot to do displacement and distance. Okay, if this is the quantity of traffic, the change in the traffic, and it said the marginal rate of the traffic, this is how much the rate at the way traffic is growing, then I want the rate and I want the total number, then I have to find the area under the change curve from 8 a.m. to 10 a.m. And so that's from, and they said t is 0 at 8, so I'm going to go from 0 to 2, integral from 0 to 2 of this. So that would be 3,000 t plus squared and divide by 2, so that'd be 1,000 t squared. And to 3, divide by 3, so that'd be minus 100 t to the third. Evaluated from 0 to 2. 0 is going to produce nothing, but the 2 is going to make 6,000 cars. And 4 times 1,000 plus 4,000 cars. And t cubed is 8 times 100 is minus 800 cars. So the number of cars between 8 a.m. and 10 a.m. will be 10,000 minus 800 is 9,200 cars. If this is the marginal cost and it costs 90,000 to set up, then the integral of this from 3,000 to 3,200, the area under it, is how much it costs for the increase in costs. So I want the integral from 3,000 to 3,200 of 120 minus 0.06 x plus 0.00001 x squared dx, which is 120x minus, this would go to 2 divided by 2, so it would be 0.03x squared, and this would go to 3, so divided by 3, so plus 0.00001 over 3x cubed, evaluated from 3,000 to 3,200. And so I put 3,000 in there. Where's my calculator? So I'm going to type in the equation. Y equals 120x minus 0.03x squared plus 0.00001 divided by 3x to the third. And then I'm going to go second table set and put it on ask, which it is, and it's a table. And I'm going to clear all these. What is going on here? Delete that. Delete that. delete that, delete that, delete that. There we go. So I want to put in 3,200, and that is 186,027 minus, and then put in 3,000, and that's 180,000. So that comes out to be 6,027 number of cost, additional cost. And the setup doesn't come into play here because this is the change in the total cost from 3,000 to 3,200. That's what the area would represent. Okay, total distance. Using left and right if we have just a table. So the left, each one of these is a half wide. So I'm going to have, for the left, I'm going to have 1/2. And the left of this first one is 0. 0. Plus the left one of this one is 12. Plus the left of this one is 20. Plus the left of this one is 29. Plus 38. Plus 44. Plus 32. Plus 35. And that was the last one, that left of the last. And then the right's going to be 1/2. So the right would be 12 plus 20 plus 29 is the right of this one. The right of this one is plus 38 plus the right of this one is 44. The right of this one is 32. The right of this one is 35. And the right of this one is 30. So there would be the total distances for the left and right estimates. And I'll leave that for you to work those out. It says we've got, this is the marginal cost increasing, and it says what's the area going to represent that's under this curve? Well, the area is going to represent the dollars per ton times the tons in tens of thousands. It's going to represent the dollars to go from this level to reducing it here, the marginal cost, the cost of the reduction. The dollars to reduce the pollution or improvement of the equality. It was an air quality one. And 22. So this was the immigration flow from Ireland, and it was a graph something like this. And so from 1988 to 1998, the area under the curve, well, there was some down, and then there's a little positive, and then there was some more down, and then there was some more positive, but the total area looked like there was more down below, I believe. Yes, than above. This one's a little flatter here, so it looked like there was more area below than above, so that means it was a negative, which means there was more leaving than going into Ireland. Okay, and so the net is a decrease. Was it inflow or outflow? Decrease. Outflow. And, oops, sorry. And then finally, at one point it was still losing people, but it was improving. Well, all this time here, there's a negative losing, but the amount losing was more here, and then it started getting less loss because there's less area here. So here's where it changed at. In 1989, it got better, and it was actually people coming in. And then it started losing in, and then right here, it started getting better again, right here. So there's two places where it started getting better, and that would be about 1994. That's what they were looking for.